time. We experience it as a continuous flow, an unbroken stream carrying us from one moment to the next. But what if that smooth progression is just an illusion? What if time itself is actually made up of tiny, indivisible units? Fundamental particles of time, called chronons? This mind-bending concept emerges from the cutting edge of theoretical physics, where scientists grapple with the challenge of unifying quantum mechanics and general relativity. These two pillars of modern physics describe the universe on vastly different scales. Reconciling them has proven to be one of the greatest challenges in science. Chronons offer a potential bridge between these seemingly incompatible theories. Just as matter is composed of fundamental particles like quarks and electrons, chronons would be the basic building blocks of time itself. But what would a universe built on discrete units of time look like? And how would it change our understanding of reality? To grasp the concept of chronons, we need to dive into the quantum world. At the tiniest scales, reality becomes fuzzy and probabilistic. Particles exist in multiple states simultaneously until observed, and energy comes in discrete packets called quanta. What if time follows similar rules? In a chronon-based universe, time wouldn't flow smoothly. Instead, it would progress in tiny, discrete jumps, each lasting for the duration of one chronon. This quantum nature of time could help resolve some of the mathematical infinities that plague our current theories. When describing the behavior of particles at extremely small scales or in intense gravitational fields. But how small is a chronon? Well, purely theoretical at this point. Some estimates suggest it could be as brief as minus 44 seconds, and almost inconceivably, a short duration known as Planck time. At this scale, our usual notions of cause and effect begin to break down, and the very fabric of space-time becomes a seething quantum foam of possibilities. If chronons exist, they would fundamentally alter our understanding of the nature of time. The smooth flow we perceive would be an emergent property, arising from the rapid succession of these discrete time units, much like how the individual frames of a film create the illusion of continuous motion. This quantized view of time could have profound implications for our understanding of the universe. It might help explain certain quantum phenomena, provide new insights into the behavior of black holes, and even offer a fresh perspective on the origin and fate of the cosmos itself. One of the most intriguing consequences of chronons relates to the possibility of time travel. In a universe of continuous time, the paradoxes associated with traveling to the past seem insurmountable. But in a chronon-based reality, time travel might be more akin to skipping between discrete states, potentially avoiding some of the logical contradictions that have long plagued time travel theories. However, it's crucial to remember that chronons remain purely theoretical. No experimental evidence has yet been found to support their existence, and many physicists remain skeptical of the concept. The scales at which chronons would operate are far beyond our current ability to measure or observe directly. Nonetheless, the idea of chronons continues to captivate researchers and fuel new approaches to some of the most fundamental questions in physics. They represent a bold attempt to reconcile the seemingly incompatible worlds of the very small and the very large, quantum mechanics and general relativity. As we push the boundaries of our understanding, concepts like chronons remind us that reality may be far stranger and more complex than we can imagine. They challenge us to question our most basic assumptions about the nature of time and the fabric of the universe itself. The search for a theory of everything, a unified description of all fundamental forces and particles, continues. Whether chronons turn out to be a crucial piece of that puzzle or a fascinating dead end remains to be seen. But the very act of exploring such radical ideas pushes the boundaries of human knowledge and imagination. As we contemplate the possibility of chronons, we're reminded of the vast mysteries that still lie at the heart of physics. From the nature of dark matter and dark energy to the ultimate fate of the universe, countless questions await answers. The concept of chronons, whether it proves true or not, exemplifies the creativity and daring required to tackle these profound enigmas. In our quest to understand the fundamental nature of reality, we must remain open to ideas that challenge our intuitions and push the limits of our comprehension. The history of science is filled with concepts that once seemed outlandish, but later revolutionized our understanding of the world. Who knows? Perhaps one day, future generations will look back on our continuous view of time as quaintly outdated as we now regard the idea of a flat Earth. The true nature of time may be far more complex and fascinating than we can currently imagine. As we continue to probe the deepest mysteries of the cosmos, from the infinitesimally small to the unimaginably vast, we're constantly reminded of the wonders that await discovery. The concept of Chronons, whether it ultimately proves correct or not, serves as a powerful reminder of the boundless potential for new understanding that lies just beyond the horizon of our current knowledge. In the end, the pursuit of ideas like Chronons isn't just about finding answers. It's about asking better questions. It's about pushing the boundaries of human thought and imagination, daring to conceive of realities far beyond our everyday experience. And in that pursuit, we not only expand our understanding of the universe, but also our appreciation for the profound beauty and mystery that surrounds us. As we conclude this journey into the speculative realm of Chronons and the quantum nature of time, we're left with a sense of awe at the depths of reality yet to be explored. The quest to unravel the fundamental nature of time continues. Driven by the curiosity and ingenuity of scientists around the world, who knows what revelations await us as we delve deeper into the nature of reality? The concept of Chronons may be just the beginning of a revolutionary new understanding of time, space, and the very fabric of existence itself. As we stand on the brink of these potential discoveries, one thing is certain: the adventure of scientific exploration is far from over. Like, share, and subscribe to Infinitonial.